Miško. Miško. Ajmo Miško.
Ja možeš se tamo uloći u ovo za čaškama, možeš ti uzeti.
Thank you very much. Zdravo nasite. Ekipa! Poleka može da продолжиме. Кой стои там позади? Ajde седнете. Ajde. Zdravo na site i dobrodošli i od mene. Ja sam Marko, Android programer vo Slovenija. Ova naša ekipa i ova prezentacija koju držam zajedno sa Filip, moj kolega od Hrvatske. So, now in English, I will tell you a little bit about how we came to build our new mobile architecture for Android. So let's start with one universal truth, that life is a constant change. And as life is a constant change, so is developing mobile apps. So when we develop mobile apps, what do we encounter? Well, we continuously add or adapt existing functionalities to our apps. We also touch up the appearance of our apps from time to time to make it look brand new and shiny. That's often a rebranding or just like grabbing attention from time to time. Technologies constantly evolve, and so must we, together with them. Some of you might remember async tasks from a long time ago. We eventually migrated to RX, and now the brand spanking new coroutines. And on all projects, people constantly change. So people come, people go, and with them some skill sets and personalities, and there are always different kind of people present on our projects. So to tackle the constant change and to rein in the chaos that change brings, we needed to set up an architecture for building new apps. So what did we need to achieve? We need to achieve extensibility in our apps, so we can modify them without introducing bugs into existing code. We could make them maintainable, which means they won't break. And also we need to make them testable so that we can guarantee quality and, sorry?
A bit louder.
A bit louder. Oh, apologies. Okay, so we need to make them testable so we can continuously guarantee their quality and they don't degrade. We need to make our code bases understandable, so when new people come to our project, they need to read their code and understand what it does, as well as adapt their own changes into our code base. And we need our architecture to be consistent, and this is a very important point. Why? Because we need the architecture to be a friend to the developer and not an enemy. We don't want them to like try and go around the architecture and do their own little shortcuts around the code. We want them to want to use the architecture. So what do we get if we achieve all these goals? We can have reliable delivery of consistently good products on a very predictable schedule, and also we can listen to Daft Punk in the meantime. Okay, so I'll tell you how our team did that through time. We started out as a very small team, so it was a handful of developers on both mobile platforms, but it steadily grew. Now there's more than 30 people on both iOS and Android teams. So in the beginning, all developers were kind of like working on everything at the same time, or like swapping between projects, and everybody knew all code bases. So you knew everything, where everything was. So yeah, and at that time, so let's think like early 2010s or even before that, everything was in one place. So it was very often possible to have God activities. I don't know if anyone remembers them, but that was like every little functionality that you can think of was all in one place in the activity class. And maybe somebody like tried to rein in that and just extracted some static functions or static classes that would help us with that, like the helper classes, the utils classes, and some manager classes. So after some time, we started to diversify, right? So as the team grew, different kinds of people came in, and some of them had a lot of experience, some didn't. Some had some skill sets, others had other skill sets. And also the projects we took on became more diverse. So it wasn't just one type of project. So in the beginning it was like telecom operators and mobile banks, but then we started doing domestic appliance and smart home applications and lots of other stuff actually. And we needed to guarantee that the builds we were delivering as a team were constantly of high quality. And to do that, we needed to make our apps testable. By doing so, we would rely on automation to cover some of that quality assurance and not dump everything on our QA team. And also, just because everything was in one place, we needed to somehow separate it so it become more clear for everybody. It would be separated using the separation of concerns principle, and it would be made into meaningful units of code. Even louder, okay, sorry. So what we found out was that we could use the MVP design pattern, which is very commonly used in UI applications, not specifically mobile, but also desktop applications, some web applications, and other applications as that. So it was actually very useful, and it was in production quite fast after we found out about it. So what are the main components of it? So it consists of the view, presenter, and model units. The view has one task, and that is to present the data to the user on the screen. The presenter takes the data from the model, which represents the state of the application at one point, and the presenter adapts it to the view for displaying to the user. And also handles UI interactions. So when you click on something, the presenter consumes that action and does something with it through the model. Okay, it was very useful and very quickly used. So yeah, when is MVP actually very useful? On applications that are cloud-based mostly. So the model and the domain logic of that application resides mostly in the cloud. So your application just adapts what data comes from the cloud to display to the user. So MVP is perfectly good for that. Yeah, those are very simple applications usually, where you fetch the data from the cloud, you do some adaptation to it so you can present it on the screen, you do that, and then the user does something with that data, and you just pass the data back along to the cloud. You reload the screen maybe, or some part of the screen, and you repeat everything from the beginning. Okay, and over time, applications weren't that simple as they were in the early 2010s, and they started to accumulate a lot of domain logic. So condition checking, validation data, some state machines and stuff like that. And all of that, while using MVP, had nowhere other to go than the presenter. So yeah, while we were trying to improve the MVP at that point, Google surprised us with a very big announcement at Google I/O. I don't exactly remember the year, but it was a few years ago, more than a few actually. And what they presented was an opinionated guide on how applications should be built. Before that, Google didn't want to have anything to do with telling you how to build your apps. They provide OS and they provide some libraries, and you do what you want. They don't care. But after a while, they saw that this was a very chaotic environment, and they wanted to improve that. So they presented us with Android Jetpack, which consisted of the guides and also all the tools that we would need to implement the patterns that they would recommend. And their main recommendation for Android apps was to use the MVVM design pattern. So let's go quickly over MVVM. It's extremely similar to MVP, with the main difference being we no longer have the presenter, we actually have a view model. As you can see, the UI interactions are still handled by it. The main difference is that it no longer modifies the view directly, so it no longer calls the view to modify its state. It actually serves the view with observable streams of data that it can use to build itself out. And therefore, while previously we had a link going from the presenter to the view, now it no longer exists. The view is separate and it stays on top. Okay, so yeah, it works. It's proven. It's in production in many other UI frameworks such as .NET. Many of you might have used it. But while we have a lot of apps in production using MVP and we want to refactor to MVVM, maybe we can do something more. Not just switch to what Google is directly saying, but include some more improvements. So what could we do? We took a look, we shopped around, as everybody does before doing a big investment, and we took a look at model view intent. It was another very similar design pattern, such as MVVM, and what we found in it was the concept of the view state. What is a view state? While MVVM recommends you expose each and every data point that the view would need to build itself out, the view state says that everything will be held into one object that will represent the whole screen at once. Okay, so in MVVM you would have many observable streams telling you like this is the address, this is the username, this is the password. Into the view state you would have one object that says user with username, with password, with address. Okay, and what does the view do in such an instance? It takes the view state, the whole object, reduces it, and distributes the changes to the individual UI elements on the screen. And one major benefit of using view states is that we can have holistic UI testing. And I will tell you a bit more about that later on. So we actually put this almost immediately into production. We thought it was that good. And it was built to last, and we still use it. It's in most of our apps since 4 years ago, if I'm not mistaken, if not more. We find it's very simple to understand and intuitive. And it's easy to test. Why is it easy to test? Because when you want to set up the screen test, you say, hey, the screen is currently in this state. The user is not logged in. And then they press this button with these parameters, and what happens to the screen? It's either logged in or there's like an error, like the password is not matching. And you can test one screen change to another through one mutation of that state. Okay, so yeah, as I said, it's in production, it works, we love it, it's great. And it, as well as MVP, actually, they were pretty good at building out the UI part of the application. But one thing actually sucked with them because they focus only on the UI. There's no guidance on how the rest of the application should look like, how it should behave. And as the applications grow and you start to build something very complex, there's nowhere for the domain logic to go. You either build it up in the presenter or in the view model. As far as those design patterns are concerned, there's nowhere else for them to go. So we thought about what can we do to tame the domain part of our applications. So everybody welcome. MVVM inspired new Infinum, clean architecture, a lot of buzzwords into one place. So we decided to double down on using clean. As well as the iOS team. Everybody loved clean, everybody loves Uncle Bob. So we decided to double down on it and also include some concepts from domain-driven design and build that into our app architecture. And just as we were about to release that, Google surprised us yet again and announced another guide, and that's the Guide to App Architecture. And wouldn't you know, it describes almost every problem that we have in our guide that you can actually find on our handbook, but it's pretty much the same thing. It's the same problems, but with a slightly different twist of the insider knowledge. So they know what technologies they're developing, so they know where to push their guide. But apart from that, they also released a series of written articles, as well as some video tutorials telling you on how you can build your apps and how you can architecture them. And to tell you more about them, so the guides, the articles, as well as our architecture, I would like to welcome my friend Filip Floreani, who will tell you more about that. Here you go, Filip.
Hand over to Miško.
There you go.
Okay, so thanks Marko for the history lesson, first and foremost. Next, just a quick introduction. I'm Filip, I come from Croatia. I'm one of the many Android team leads currently at Infinum, and I've been working in Android for the last 5-ish years. This is my first time in Skopje, so please be gentle. And just one additional question before we continue. How many of you do Android? Hands up. Damn. Okay, I can go technical a bit. Cool. So we have this MVVM inspired thingy. Let's tear it up. Looking at it from afar, we have 3 big layers, and then we have some components in those layers. You can treat components as your basic building blocks of an architecture. So they're the entities that go down into classes and implementations and everything else. And then you have those layers that are kind of grouped components that make sense working one with another. Whoops, wrong click. And now these are the building blocks, but you need something to hold those building blocks together. And this is something that we call ACL. Basically, consider it as the glue that holds this whole thingamajig together. What is this ACL? Apparently, it's everywhere. So ACL actually stands for the anti-corruption layer, and we mean layer because we don't technically consider it as a separate layer. We have 3 of those, and ACL is kind of in the background. It actually stands between different components and between entire layers. Its job is to separate contexts. So we don't want the UI to know something within domain. We don't want domain to know something within data layer. That's why we have the ACL. Usually these are implemented as mappers, parameter classes, converters, you name it. There's a whole bunch of the implementations. But that's the general overview of ACL. Going into each layer, we're going to start with the UI. That's something that we're all most accustomed to, and it's like the easiest one to explain, so we can abstract from it further. The UI layer has 2 components and 1 additional thingy that we might consider a component. First is the view, the basic, most common component that actually shows something and draws something on the screen. And then we have the view control, which is pretty important here because it controls data, it controls UI logic, and it makes the view work in some way. The ViewState here is, well, Marko already explained what the ViewState as a concept is. It describes the UI at any given moment, and we kind of consider it one of the components that is ACL, where it kind of defines based on data that it receives from the domain layer and every other layer, and it uses that to modify the data and show it within the UI. So one by one, first off, the view component, and we're gonna go over each and every component. On the right, you're gonna be seeing pseudo-code-ish implementation of it with the most important parts, and on the left, you're gonna be seeing what you can and what you shouldn't be doing within that component. The view is pretty, well, dumb. As dumb as humanly possible. It needs to do 2 things, and it needs to do them good. First, it needs to consume the view state that it gets from the view model. It actually observes that view state, and based on it, it needs to draw something on the screen. Then we also have the inputs that the user puts through the screen. It clicks something, inputs something, text, whatever. The view should actually take that and move it along to the view control, which will know what to do with that. What it should not do ever is contain logic. The logic belongs to layers and components further above. So moving on to the view control, we usually implement that as view model, this and extend from view model within Jetpack. What a view model should do is it should receive data from the domain layer, from other components, and construct view states based on that data. Also, once it receives those interaction events from the view, it should decide what to do with them. So either navigate or create a new state based on that, or ask for more data or send more data into other layers. Finally, since this is the last component that before the view that actually has some logic within it, it should also handle errors gracefully. And the only logic that it should contain is the UI logic. So it should know how to show something, but it should not contain domain logic, what to do with certain data. Comparison of this to what Google presents in their math skills is our view is mostly the same, so it needs to be done, and the important part is that it should be framework independent, so it should not matter if you implement that in the old, so-called Vue framework with XML, or use Compose, or maybe something else. Regarding the Vue model, again, mostly the same. Google really implies that it should have state immutability, and we also agree with that. And finally, they also mention something called unidirectional data flow, which again, we agree with, and it's mostly shown in this graphic here. The only thing that we kind of fight on is what are events. So Google actually has our own definition of events, which are one-off things that come from the Vue model to the Vue, but they also show events as something that happens on the Vue and moves into the Vue model. These are all those interactions that we talked about. Actually, Google just today released a new blog post article talking about those one-off events that go from the Vue model and into the UI and how to implement them correctly. Moving on to the domain layer. This is the place where gods, or at least god activities, and all those managers and classes that we just pushed around, this is where they come to die. So we were at the view control component, and now we move on to the entire domain layer with the logic aggregate as a component. It serves the purpose of mixing various domain models into something that's feature specific. Then we have the domain definition, which actually defines one domain model. It combines and manages multiple different sources to provide operations to that one domain model. And we have the source interface, this is our naming. The source interface that's kind of separator between the data and the domain layer, where it kind of abstracts away what happens in the data provider. Going in one by one, the case of the use case. So we call that our logic aggregate. So the use case is basically a feature-specific part of domain logic. It groups together everything that is concerning one single feature. It can combine multiple repositories, multiple other use cases. So the only thing that you should be worried about is not mixing different features. That's why you have other use cases, and then they can be intertwined together. One additional thing that you should not be doing is mutating data. So leave that to the data layer or some other components upstream, and just use the data that you have and just move it along one way or the other. Coming down into the repository, or actually coming up into the repository, the repository is what we call the domain definition, and we usually implement that in the repository pattern. You can use a lot of different things, factories, adapters, you name it, but repositories kind of fit in here nicely. What they should do is, again, combine everything that's related to one single domain model, and they should return, and by return actually move downhill, so into use cases, into view models, only data that's specific and that's needed for those components and the UI layer. And one more thing, what you shouldn't do in the repository, so we said they care for one domain model each. You should not mix models within the same repository. And finally, we have that interactor, which is our source interface, let's call it. The interactor is just a component that should hide the complexity of the data layer and the components within it. Usually it concentrates on one-shot operations that are CRUD-like, and the only thing that you should watch out for is mixing different sources, actually different upstream dependencies. how does Google pitch in here? So they actually do have a domain layer, which is totally optional, but in that domain layer, they only have the use case. Regarding the use case, we kind of match opinions here. So it's the same position between the view model and the repository. We agree that it should be main thread safe. So either we should do threading within the use case, or we should do threading somewhere upstream in other layers and components. We should also unit test that because that's our main part of the main logic. And it is technically an optional component. You don't have to have it in the architecture if you don't need it, if you're going to be having some simpler features. The repository, well, they don't have it here. They actually moved it into the data layer. We sometimes agree with that, we sometimes don't. We have some projects that have repositories in the data layer. Ours usually is found in the domain, and that's because our sources and repositories are pretty similar here. So it's just a matter of where you draw the line in between the layers. And finally, we have those interactors, but Google doesn't mention them anywhere. So why we use them is just so that we have some nice wraparounds that kind of distinct our domain and data layer. And coming into the last layer, the data layer, we were at the source interface, our interactors, and we just move along and we just have one single component, which is the source, technically a contract with a certain data provider. The source is relatively simple, so it just wraparounds a given data provider. That can be retrofit, that can be room, that can be shared preferences, or anything else for that matter. And the only thing that it should do is expose data as individual models that are prepared to be handled by the domain layer. What you shouldn't do, combine multiple different data providers into a single source. And that's it. Comparison to Google is, well, we commented repositories. They were in our domain layer. Regarding the source, generally they are CRUD-based operations, but we kind of have that as a given, based that we use retrofit, we use databases, we use a lot of different things that are already CRUD-based. We should reuse sources throughout the app, so thank God for dependency injection, and we can use that as a singleton. And finally, we should expose errors from the entire data layer in a unified way so that we can expect how to handle them down in the domain layer. So that was mostly it for our architecture. What the future holds, we're not really sure. We only know based on the history that Marko told and based on this that I just covered. We only know that changes are going to be inevitable. We can't escape that. Something is going to change, either the OS or the devices or anything else for that matter. And there's just no silver bullet to going into app architecture. So we have a bunch of different things implementation-wise that are still questionable. For that, stick on and stay in touch. You can use our email addresses, you can use our handbook that Marko mentioned for everything detailedly described what we just did here. And thank you very much. Ask away. Yeah, go ahead.
Yeah, I'm curious on what you think for modularization.
Mm-hmm.
Do you have any specific rules that you guys follow? Because you have good rules and stuff, or maybe did you do it by feature? Did you do it by feature and also by layers, or what's your take on that?
Yeah, it's a good question. It does have a lot of touch ground with architecture. So we have a couple of projects that we modularized. I think some are actually by feature and some are by architectural layer. Everything that's described here should actually be beneficial to modularization because you just take these layers and components and you can split them up any way you wish and like. Cool. Any other questions? Okay, I guess that's it. Yeah. Oh, and just one last question before you're disbanded, and feel free to take more drinks. Is anyone here that has signed up for the Infinum Academy this summer? Okay, that's a lot of people actually. Cool. Okay, feel free to stay here and mingle. The bar is open. There's food here if I hear well. So enjoy the rest of the day. Thank you.
How do I stop the recording?